We are going to solve some preliminary or sort of introductory problems on circuits just to get a feel for how it works. And I've got some animations to help me out. Number 1, find the potential difference lost across resistor X. The battery gives charges 20 volts of potential difference. Think of that as the energy. Where is the energy being lost? Because by the time they get back to where they started, they can't have any extra energy. They have to have lost everything that they have gained. And so where is the energy being lost? Well, 12 is lost here. So that means we need to lose the other 8 volts right here. That makes sense if you consider the falling ball analogy. So here's the battery. It pumps up those charges, giving them energy. They lose some of their energy here. They lose the rest here. And if you add it up, it has to equal how much they gained at the beginning. Number 2, find the potential difference across resistor A and resistor B. Well, here's the positive terminal. Here's the negative. The positive is longer, so charges are traveling this way. Okay, so charges lose some of the 60 volts here. They lose the rest of the 60 here. How does that get divvied up? Well, these have the same resistance value, 2 ohms for each. And if it's equally hard to get through this guy as it is equally hard to get through this guy, then the same amount of energy is lost getting through both. So we're going to have that 60 volts split evenly if the resistance is equal. What if this is twice the resistance as this? Well, this gets 2 parts of the 60, and that gets 1 part. So what does it turn into? Without doing any complex math, we can figure out that this will be 20 volts and 40 volts. We'll learn this formally in an equation, but it's nice to get an intuition for it. So if you look over here, if the first one is small and the second one is big, then you're falling less on that first resistor, and then you're falling the rest of the way on the second resistor. Let's look ahead to the next question. Find the current through resistor Y. 10 amps of current flows this way out of the battery, and then right here the current splits up. Here's how that looks. 10 amps reaches this point. They've told us that 3 amps goes down this first path. How many charges flow through the second path per second? Well, the charges can't just disappear, so if you got 3 this way, you need 7 this way to add up to our original 10. So the answer is 7 amps. Travel through resistor Y. It's as simple as that. Number 5 is just as easy. Here's the cell. The longer side is the positive terminal. That's where charges flow out. We've got 20 amps of charge flowing every second. And so right here, some of the 20 goes this way, the rest of the 20 goes this way. How does that 20 get divvied up? Well, the 2 paths are equally resistant. It's just as hard to go through the top as the bottom. And so the current splits evenly. 10 amps here and 10 amps here. We're not going to solve 6 and 7 mathematically. In fact, we won't look at 7 at all. All I want to ask you is when the 20 amps, here's the cell, the battery, 20 amps comes out. It splits, some of the 20 goes here, the rest of the 20 goes down. Which path do you think will get more current? Well, this path is easier to flow through. This one is harder to flow through. We're not going to worry about the math. I'll go ahead and tell you 18 amps ends up going through the top path, 2 amps goes through the bottom. Maybe you can figure out why that is. And likewise, which path here, right, where your 20 amps comes down, some of it goes this way, the rest of the 20 goes this way. The charges flow through the path of least resistance, generally speaking. So you've got a bigger current on top, and you've got less current because the total resistance here is 6. 3 plus 3. Right, the charges that go through the first resistor have more resistance to get through. So C, can you figure out, right, if the total resistance is 6, how much current do you think might go through the top? How much through the bottom? We haven't learned this, but maybe you could figure it out. Well, it turns out that the answer is, let me do the math, 4 and 6, that's 10 parts. So each part counts for 2 amps. So this is going to have 12 amps this way and 8 amps this way. Next page. Find the potential difference across resistor X and resistor Y. Alrighty, here's the picture. Remember that charges traveling through X, right? If a charge goes like this, it does not travel through Y. And if a charge goes like this, it does not travel through X. Any charge that starts here, gains 15 volts, will lose 15 volts as it travels through the path if that's where it heads. Right, so any charge traveling through the first path loses all 15 volts right here. A different charge will choose the other path, and it has to lose its 15 volts on the other path. So what do we notice? By drawing those little loops, those circles, the potential difference here has to be 15 and also across Y. It feels like we're gaining energy, right? It feels like, how can we make, we're losing 30 volts total, but we're only giving 15 volts of input. Well, remember that the 15 volts is how many joules per coulomb. And you have some of the coulombs going this way, the rest of the coulombs going this way, and so when you add up per coulomb, it works out to be the exact same energy as you gain from the battery. But this is an interesting fact. Parallel paths dissipate the same resistance, the same potential difference. Okay, number 9. The battery gives 18 volts. You know how to work this now. You draw a loop like this. Charges on that loop have to lose their 18 volts on this resistor. So that's our answer. And then if we consider the other path that different charges would follow, they have to lose their 18 volts right here. And it doesn't matter that this is a higher resistance than this. All that means is that more current will flow this way, and less current does the green path. 10. Find the potential difference across B and C. Draw your loops, right? That's a really good trick. So you gain 12 volts, you lose 4, and how much more is there to lose? 8 across resistor B. Do the same thing, you gain 12 in the battery, you lose 4, and how much was there that we had to lose in C? 8 as well. Number 11, find the potential difference across resistors Z and X. Draw your loop. You gain 10 in the battery, you lose 4 here, so that means you had to lose 6 more here, so that you lost as much as you gained. And then draw another loop. You gain 10 in the battery, you lose 4, you lose 1. How much did you lose in Z while traveling through Z? Well, you lost 4 and 1, that's 5, and so the amount remaining to lose was 5 volts. 12 and 13, and then we're done. If you travel this path, you have to lose all 4 volts across resistor X. And if you travel this path through the bottom, you have to lose 4 volts, but you have it happen across 2 resistors. So how do you know how much the 4, like is it 3 volts here and 1 volt there? Is it 2 and 2? Well, notice that their resistances are the same. It's just as hard to get through this as it is to get through this. So you're going to lose 2 volts on each. If the resistance is the same in series, then they share the potential difference equally. Final one, you gain 5 in the battery, you have to lose that 5 right here. Did we already do this? And then if you draw the other loop, you gain 5 in the battery, you lose 3 here, so you would have to lose the remaining 2 right there. And that's how you solve these problems.